Okay, so we're back for part 2 here. We're on the back of these notes. Number 4. So we've got 4 parts to this, and we've got this picture over here with a lot of triangles drawn. Part A asks, which triangle is a translation of triangle GHI? GHI is here. Okay, so translation means slide or glide. So we're going to shift this, we're going to move it, but we're not going to rotate it, we're not going to reflect it. So we're looking for another triangle on the graph which looks identical to this. Same direction, same everything. And if you look at triangle STU, notice it's the same orientation. It's pointing the same way. That is a translation. So the answer is triangle STU. GHI matches to STU. It doesn't say to name the translation or to state the numbers, but we would have to go, we'd actually have to approximate. This is kind of in the middle of nowhere here. 1, 2, maybe like 2.5 to the right, and then down. 2, 3, 4, 5, 6, 7, about 7. Okay, so like right 2.5, down 7. Part B, which is a reflection across the x-axis of triangle GHI. Now the x-axis is here, so we would take this triangle and flip down if we flipped it over. So you would land on this triangle, which would be JKL. So that would be triangle JKL, which is a reflection across the y-axis of triangle GHI. So here's GHI again. Now the y-axis is this. We're on the right side, so we would reflect it to the left side, so that would match to ABC. And the last one, which is a 180-degree rotation about the origin of triangle GHI. Now the origin is 0, 0. So imagine that you take this and we're going to spin it around this point here. So this whole thing is going to spin. If we spin 180, we would only go halfway. So it doesn't matter if we spin it clockwise or counterclockwise, but if this goes halfway around, then this triangle is going to end up here. If you're in the first quadrant, 180 degrees will put you in the third quadrant. Okay, you'll go halfway around the graph, basically. If you were in the second quadrant here, 180 degrees would put you into the fourth quadrant. Those would match up. So in this problem, triangle GHI would match or correspond to triangle MNO. So I put triangle symbol MNO. Okay, and that's it for that. Now the last section here is dilations. Dilations are where we enlarge or reduce. So you make an object bigger or smaller in the same way. So number 5, what is the scale factor of the smaller triangle to the bigger one? Now we're going to be getting into similarity in our next unit. And that's going to be one of the words. Scale factor is basically comparing the sizes of the sides. So these two figures here, you can see that this figure on the right has been enlarged from this one. What's the scale factor of the smaller triangle to the bigger one? So in this case, from the smaller to the bigger, I'm going to compare. The 6 would match up here with 18. The 5, I'll use a different color, would match up to 15. The 3 would match up to 9. Now one thing you might notice about all of these is that if you reduce each fraction, you will get the same ratio, which is 1/3. That, we usually label that with a lowercase k. That is the scale factor. That's the ratio of the sides. The scale factor is the ratio of the sides. So in other words, the big triangle is 3 times the length of each side of the small triangle. Okay, but since we're comparing the smaller one to the bigger one, we'll write it as 1/3, smaller to bigger. Now you can also write a ratio this way, as 1:3. We would read that 1, 2, TO, 3. Okay, so the fraction is good, but so is the ratio. Right there. All right, so the last one here, number 6. In the triangle on the right, draw the image of triangle ABC. So here's ABC. After a dilation with a scale factor of 1/2, list the coordinates of triangle A prime, B prime, C prime. Well, here's the thing. Okay, if we take point A from 0, 0 to 0, 4, that's a distance of 4. And then from C to B, 1, 2, 3, 4, 5, 6, that's a distance of 6. If we want to draw a triangle with a dilation for 1/2 is the scale factor, basically we're going to take half the distances. Now, we're going to keep C where it is, but half of 4 would be 2. So I'd put point A prime at 0, 2. Half of 6 is 3, so I'd put point B prime at 3, at 3, 0. And if you draw this, that would be the new triangle. So the coordinates, A prime would be 0, 2. B prime would be 0, 3. 3, 0, excuse me. X, Y. Now, C prime would not move. C prime would be 0, 0. Okay, so if you know the distances of the sides, well, if the scale factor is 1 to 2, basically take half of the distances and then you plot. And that is the end of the notes.